Hello and welcome to another Algebra 1 video tutorial. In lesson 11.8 we'll be looking at the chi-square statistic. Our goal will be to use the chi-square statistic to determine whether a set of discrete data differs significantly from values that would be expected when certain probabilities are given. Alright, so let's suppose a spinner is divided into 4 regions labeled A, B, C, and D, and region D is twice the size of each of the other 3 regions. So let's say we have region A, region B, C, and then D is twice the size of the other 3. Okay, so if you spin the spinner 100 times, how many times would you expect the spinner to land in region B? Okay, so since we have 3 of these are the same, and D really counts as 2, so really we can think of this as 5 parts, where D takes up 2 of them. And if we took 100 divided by 5, that's 20. So we'd expect B to land in there 20 times. So region B, we would expect 20 times. As well as A and C. If we're doing that, let's figure out the other 3 as well. So region A we'd expect 20, region C we'd expect 20, but what about region D? We'd expect 40 in that case because it would be 2 of the 20 regions, which would make 40. Alright, so let's suppose, we're going to test the fairness of this. So let's suppose the spinner landed on A 17 times actually, so we actually did this 100 times. B would happen 25 times, C is 24 times, D is 34 times, and for each region let's calculate the actual value minus the expected value, square it, and then divide it by the expected. So that's where, and we're going to do that for each frequency, so we're going to have 4 of these. So A is the actual and E is the expected. Okay, so what we're trying to figure out is this a fair spinner? So what we expect, you know, and in a real experiment, we would never get 20, 20, 20, and 40. We might get something like 17, 25, 24, and 34. Is that about what you expect, or is that far enough off? And this chi-square statistic will test that, whether it's far enough off or about what we expected. So for region A, let's do actual minus expected and square it. So region A was 17 times, so that's the actual, so it goes 17 minus 20. Square that difference and divide it by what you expect, which is 20. So in this case, it's going to be negative 3 squared, which is 9, so 9/20. 9/20 for region A. Okay, region B, actual was 25, so 25 minus the expected of 20. Square that difference and divide it by 20. So 5 squared is 25, so you'd get 25/20 in that case. Region C happened 24 times actually, so 24 minus we expected 20. Square it and divide it by 20. So 4, difference of 4, square it is 16 divided by 20. We could reduce these if we wanted to, but it's not necessary at this point. Okay, and then region 4, region D, actually 34. We expected 40 because it's twice the size of the others. Square that difference and divide it by what we expected, 40. So that would be negative 6. Negative 6 squared is 36, so that would be 36/40. Okay, then what we're going to do is we're going to add those 4 numbers we just obtained from question 2 to find what we call the chi-square statistic. So we take our 9/20 plus 25/20 plus 16/20 plus the 36/40, and we get 3.4, and that's our chi-square statistic value. And how are we going to use that to determine something? Well, we're going to use row 3 of the table from page 699 to determine whether the frequencies differ significantly from what would be expected just by typical variations. All right, so there were 4 events, 4 regions of the spinner. So we go to row 3 because there were 4 events, so we subtract 1, go to row 3. Now we compare to these numbers here, and we got 3.4. 3.4 doesn't even show up on the chart because how you read this chart. A number, or kind of like a difference squared, the chi-square statistic, a difference of the value or chi-square value of 6.25 or larger would happen less than 10% of the time. Okay, 7.81, a number that large would happen 5% or less of the time. And a number as high as a difference like a 16.3, well, it's not just a difference, it's the chi-square values added together. Would this value of high of 16.3 would happen less than 1 in 1,000 times. Okay, so 3.4 is a low enough number. It's going to happen more than 90% of the time. So it's not significantly different. So it's low enough to say the spinner's fair. There's no reason to believe that there's a magnet underneath region C or something to cause this to be an unfair spinner. So this is a fair spinner because this chi-square statistic value is not very high. So it's occurring randomly, or what we expect. Okay, so in 1900, the English statistician Carl Pearson introduced the chi-square statistic as a way of determining whether the difference in two frequency distributions is greater than that expected by chance. Okay, so it looks like chi, but we call that chi, so the chi-square statistic. And the algorithm for calculating this statistic uses the squares of deviations, so that's why we study it in this lesson. So to review, how to calculate the chi-square statistic, which we just did. Step 1, count their number of events n. So in the one we just did with the spinner, there were 4 events because there were 4 regions, so n was 4. Step 2, let a sub 1, a sub 2, up to however many events you have, a sub n, those be the actual frequencies, so you may need to do an experiment. Step 3, let e sub 1, e sub 2, up to how many events you have, be the expected frequencies, and sometimes you have to calculate that using probabilities and what you expect. Okay. Then step 4, calculate the difference between actual and expected for each individual event, and square that and divide it by the expected. And then step 5, add those numbers from all the events. So if there's 4 events, you're going to have 4 fractions to add. If there's 10 events, you'll be adding 10 of them. So add the numbers from step 4, and that sum is the chi-square statistic. And really there's a step 6, go to the table and compare the frequencies in the table, the values in the table with their probabilities, whether it happens less than 5% of the time. So that cutoff is the 5% range for that. Okay, and we'll go over that again too. All right, so this chi-square statistic measures how different a set of actual observed scores is from a set of expected. So it's just the difference squared of actual and expected, and just measures the difference to see if it's what you expect or not. So the higher that value is, the higher the chi-square value is, the less likely it is to be occurring randomly. So there's something causing such a big difference. So the one example in the book is that they're trying to test whether there's more births or less births on the weekend, and you'll have some homework questions about whether there's more accidents on the highway on the weekend or on the weekdays, and use the chi-square value to kind of test whether it's about what you expect or is it high enough. There's a difference, meaning there's a reason that there's causing those big differences. Okay, so we define the chi-square statistic as a member calculated from data to determine whether the difference in two frequency distributions is greater than that expected by chance. So if stuff is happening randomly or not. All right, last example we'll look at. The table below shows the weather forecast based on a new method and actual temperatures for a week in November. Is there evidence the new method is unreliable? So we have measured the actual high compared to what was predicted or expected. So the new method is going to predict, so it's what we expect. And we don't want a big difference. We want our weatherman or our formula for predicting weather to be fairly accurate. So we don't want a big high chi-square statistic value, we want a low one. So let's test that. So we're going to have 7 days of the week, so we're going to have 7 chi-square values. So for Sunday, we do the actual, 66, minus the expected, or predicted, which would be expected, divided by what you expected, 46. Okay, plus, go to Monday, so we do actual minus expected, or predicted in this case, divided by what's expected. Go to Tuesday, 57 minus 52. You'd probably do some of this mentally, but I'm going to write it out here so you can see it all out. Plus, okay, go to Wednesday, 58 minus 55. And what I meant by mentally is 57 minus 52 is 5. 5 scores 25. You may just write 25 over 52. Okay, but I'm writing this out to see it all. Divided by expected. Okay, go to Wednesday, 56 minus 61, that quantity squared, divided by what's expected. Friday, 50 minus 52 squared, divided by what you expected, 52. And Saturday, 42 minus 56 squared, divided by what you expected. And did I get all 7? I have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Got them all. All right, so now we go to calculate these out. You can use a calculator if you want, or some of this you can do mentally. 66 minus 46, that's a difference of 20. 20 squared is 400, so it's going to be 400 over 46, plus difference of 5. 5 squared is 25. 25 50ths. I could have wrote 1/2 if I wanted to. Difference of 5. 5 squared is 25, so 25 over 52. Difference of 3. 3 squared is 9. 9 over 55. Difference of -5, but -5 squared is the same as 5 squared, so 25 over 61. Plus difference of -2. -2 squared is 4. 4 over 52. And plus the last one, a difference of -14. -14 squared is 196 over 56. If you add those all up, what do you get as a decimal? It's about 13.8. You don't have to go to too many decimal places. We just need the ballpark answer. So nearest tenth is usually fine. So a difference, or a chi-square statistic value of 13.8. Now we go to the table. We have 7 events, so we go to row 6, and we look at 13.8. So 7 events, because there were 7 days, we go to row 6. Row 6, we had a 13.8. 13.8 fits in this category because it is higher than 12.6, and this is kind of that cutoff where if it's higher than this value in the 5% range, meaning that value that high is not supposed to happen. It's only going to happen less than 5% of the time. It is closer to 12.6 than it is 16.8, so we'd say it's closer probably to the less than 5% range rather than if it was over 16.8. That would happen less than 1% of the time. So, but since this was in the 5% range, 5% probability range, that means that that's not what we expect. What was predicted is not what was supposed to be happening or what actually happened. So it's high value. So we need either to do more research on this, so further testing probably. We need to test another couple weeks maybe. Or this is enough to say this new method is unreliable because there's the difference between expected and actual is a little bit too big. Chi-square statistic value shows that. All right, so that wraps this up. Your assignment will be 11-8, page 700, 2 through 16 evens. Thanks for watching, and we'll see you next time.